Venice looks timeless, but it's built on water that refuses to stay calm. When high tides push into the lagoon, the city doesn't just get wet, it gets attacked. Salt water crawls across stone, into homes, into shops, into history. People don't fight it with machines at first. They fight it with quick fixes and panic. But the sea is patient and salt is brutal. Sensors watch the tide like a heartbeat monitor because minutes can decide everything. The danger enters through the lagoon's inlets, the gateways where the Adriatic can surge inside. So the question wasn't, how do we drain Venice? The question was, how do we stop the sea from entering at all? And the answer had to be massive, mechanical, and reliable. The solution became a sea barrier system unlike anything the city had ever seen. Not a single wall, but rows of gates anchored to the seabed at multiple inlets. And to build it, engineers had to work in the worst place possible, open water, because waves don't pause for construction schedules. The foundation began with piles and heavy marine work that shakes the entire platform. Concrete followed, but this wasn't normal concrete work. This was precision casting for an underwater machine. Giant housing structures would become the beds where the gates sleep. Moving them required barges, cranes, and slow-control logistics. Because in water, a small mistake becomes a big drift. Some construction demanded temporary basins and sealed work areas just to create a dry environment. Mud had to be removed, leveled, controlled. Underwater alignment had to be planned like surgery. Rock mattresses and seabed preparation turned soft ground into engineered support. Then the massive housing units were floated out like concrete ships. They were guided into position at the inlets, centimeter by centimeter. Workers signaled, tugboats pulled, and everything moved slowly on purpose. A floating crane lowered the structure into place. Water surged around it as it seated, testing the fit instantly. And when it locked into position, the seabed gained a permanent foundation. But barriers don't work if the sea can simply tear around them. So breakwaters and armored protection had to be built to calm currents and defend the site. Curved stone lines shaped the water like sculpted resistance. Artificial platforms and islands became technical hubs between gate rows. Navigation had to continue even when gates were raised. So lock structures were built as part of the system, because ports don't pause for tides. Walls rose, reinforcement tied, concrete poured, and mechanics installed.
Watch for voids. Adjusting now. Good level. Ease off.
Steel components weighted on racks like parts of a giant clock. Basins filled for tests, and the system began learning how to move. Because in flood defense, the real enemy is not water. It's failure under stress. While concrete work shaped the seabed, steel work shaped the gates themselves. Thick plates were welded into box-like structures designed to hold water, or expel it. The hinges became the heart of the system. Heavy machining turned raw steel into precise movement points. Bolts were torqued, pins aligned, tolerances checked again and again. Then the gates
Easy
were
now,
lifted
keep it
like
steady. Got
skyscraper
it.
walls,
Pulling left.
transported, staged, prepared for the sea. Loaded onto barges, the gates traveled toward the inlets. The water looked calm, but the operation was never simple. Salt spray hit the steel before it even entered service. Installation looked like choreography on a knife edge. A gate had to meet its hinge points perfectly. Lowered into position, it became part of the underwater row. The hinge rotated under load, and the system gained a moving muscle. Gate after gate, the rows grew into a hidden line beneath the surface. Behind the scenes, pipes and valves formed the system's lungs. Compressors and technical rooms became the invisible power of the barrier. Access tunnels carried cables and systems like veins under the water. Every line had to survive moisture, pressure, vibration, and time. Technical buildings stood above, while the real machine slept below. Then comes the moment the project was built for. A dangerous tide is forecast. The decision is made. Warning systems activate. Procedures begin. Wind rises over the lagoon and the water starts pushing harder. Sensors confirm what eyes can't measure fast enough. Currents accelerate through the inlets like a doorway left open in a storm. And then, the seabed moves. A gate edge breaks the surface, shedding water like a metal fin. One gate rises, then the next, then another, until a line begins to appear. The trick is physics. Compressed air drives water out of the gate, making it buoyant enough to rotate upward. In minutes, the barrier becomes visible above the surface. Behind it, the lagoon calms, protected from the worst surge. On the seaside, waves slam into the raised steel like an angry test. From above, the system looks like a hidden city waking up to defend the real one. Locks keep essential navigation alive when gates are raised. Water levels shift inside chambers, controlled and deliberate. Operators monitor every movement because the difference between success and failure is measured in details. When the storm passes, the system must disappear again. Gates begin lowering with smooth mechanical control. Water returns into the gate, weight increases, buoyancy fades. Slowly, the steel rotates down into its housing. From the surface, the barrier vanishes, leaving only calm water and a city still standing. But the fight doesn't end after a single closure. Salt water is a constant attacker, and maintenance becomes a second construction project. Technicians work in confined rooms, checking systems that can't be allowed to fail. Seals, coatings, and components are replaced before weakness becomes disaster. Inspections happen again and again because this machine must work for decades. On calm days, you can forget the barrier exists, and that's the strange success of flood defense. The best system is the one people stop thinking about. Yet projects this massive carry pressure beyond engineering. Delays, controversy, and doubt can surround the work. But the sea doesn't care about headlines. It only cares about openings. So the system had to be finished, tested, and proven in real conditions. A full test isn't a celebration. It's a verdict. Either the city stays dry, or history gets flooded again. And when it works, the difference is almost invisible. People walk where water used to be. Shops open without barriers. Boats move under sun instead of under sirens. The lagoon breathes normally again. Operators log the event and prepare for the next one. Gates rest on the seabed like sleeping armor. Sunset arrives and the city looks untouched. But the control lights still glow because readiness is part of survival. Deep below, hinges and seals wait for the next signal. And Venice continues because a hidden machine stands between it and the sea. Built with concrete foundations, steel giants, and relentless maintenance. A barrier that rises only when it must. And when it does, it turns an ancient city's greatest threat into a controlled event.